Alright, ladies and gentlemen, time for a lesson about similarity and parallelograms. Well, it's a little bit less about similarity and more just like all these different properties about parallelograms, but the last thing was called similar triangles, so we'll just continue on with it. And there's similarity there. Anyway, so yeah, this lesson has a whole bunch of parallelograms in it, and you have to use the properties of parallelograms to find out unknown values, like what would the B be in this case. So just a lot of different theorems, a lot of things involved there. But before we get into those actual theorems, we need to knock out some geometric notation and vocab words. First things first, a polygon, it's a shape made of sides. And sides are line segments. And if a polygon has four sides, we call it a quadrilateral. Quad being the prefix for four. And so yeah, any four-sided shape is called a quadrilateral, like squares and rectangles and kites. Those are all quadrilaterals. But a quadrilateral with two pairs of parallel sides is called a parallelogram. Just the opposite sides are parallel to each other. And some other notation thing. A segment that connects two non-consecutive vertices is called a diagonal. So consecutive means next to each other as you go around the shape. And if you have a line that goes across, it's called a diagonal. Fancy, I know. If you have a parallelogram and it's full of right angles inside, then we call it a rectangle. And if it's a rectangle and all the sides are the same length, we call it a square. You know, just kind of some things about quadrilaterals you might have heard before. But yeah, now we're going to hit the theorems about parallelograms that you need to be aware of to solve all the stuff, all the problems you got today. So in a parallelogram, meaning opposite sides are parallel, so I'm going to add these marks on here. If two line segments have the same number of arrows pointing the same way, they're considered parallel. So that's how we notate opposite sides are parallel here. Well, if it's a parallelogram, then opposite sides are congruent, meaning, I'm going to take these marks off real quick. This side over here is the same length as this one. And also this bottom side here is the same length as the top one. So I'm going to add these congruent marks, little tick marks in the side. And the next one, so that's one property. That's going to show up. We'll see an example of that. Next one, if a quadrilateral is a parallelogram, then opposite angles are congruent. Meaning, this angle here and this one straight across from it is congruent. Those are congruent. And then these two here are also congruent. That's going to show up too. Next one, if a quadrilateral is a parallelogram, then the diagonals bisect each other. So remember, a diagonal goes from one vertex to the opposite one. And if we draw two of them, these bisect each other. And bisect means to cut in half. And it's not sort of in half, it's exactly in half. And that means this segment is going to be the same as this one. And then this segment here is going to be the same as this one. The diagonals cut each other exactly in half, meaning the two halves are going to be congruent to each other. So is that one. And then if the diagonals of quadrilaterals bisect each other, the quadrilateral is a parallelogram. That just means if for some reason you don't know it's a parallelogram and you have two diagonals bisect each other, like, oh, we know this. Then you could be like, okay, then these sides are parallel and these sides are parallel. I don't think that shows up a whole lot on this assignment, but yeah. And the next one, if the diagonals of parallelogram are congruent, then the parallelogram is a rectangle. And that's just saying, right, again, we got two diagonals. And we're going to label these. We'll call this A, B, C, and D. If AC is congruent to BD, side BD, then this would be considered a rectangle. You can be like, oh, okay, these are right angles, it's a rectangle. Again, it doesn't really show up on this assignment, but it's a thing to know about parallelograms. It's going to show up later. And then the last one here, I had to kind of hand draw this, but the sum of adjacent angles is 180. So if you got a parallelogram, this angle and this angle are supplementary. They're going to add to 180. And so you can just put that like x plus y equals 180 degrees. Okay. So a lot of different properties, things to know about. I did want to mention a little bit about this notation. If you want to say a side, you just put the endpoints, or you want to say a segment, you put the endpoints, so A to C, and then you put a line over, a little line segment over it, and that means segment or side, AC, segment or side, BD. And then the symbol here in the middle, that means congruent to. And that shows up a lot in geometry. It's going to show up during the rest of this unit. So be familiar with that. Don't be weirded out. It's like equals, but with shapes. Yeah, that's what congruent is. All right, so now you've done that, we're going to use different properties, mainly these ones. Well, actually, mainly these ones, and then this one down here quite a bit in solving these problems. And so, let's dive in. So we got a few examples we're going to go over. We're going to go over A, B, and D so you can see them. So if I look at A, I see I have these opposite angles here. Well, I want to find out what B is, and I know from my second theorem here, opposite angles are congruent to each other. So I can set this equal to this and solve that equation. So I got 6b minus 10 equals 120. Let's add some 10, add some 10. And then we got 6b equals 130. And then you divide by 6. And that does not go evenly, but that's okay. Let's see, 130 divided by 6. You can divide both by 2. You get 65 thirds, which is fine. You can get fractions. Fractions are totally a normal number that shows up. Let's go to B. So to solve this one, you notice we don't have any angle information. We don't have any side length information. We just have these diagonals, and it has a bunch of like variable words in it. Well, variable expressions in it. Well, that's actually going to use this guy here. Actually, sorry, I'm going to go up. It's going to use this one. If you have a parallelogram and you have diagonals, the diagonals bisect each other, so it splits it into two equal pieces. And that lets you know that, well, we can take this, and they're equal to each other. They're congruent. And the same with these two here. So I can create an equation using the different halves of the diagonals. So I got 2y minus 5 equals y plus 7. And I'm going to write the other one in a different color. Let's do these ones in purple. We got 6z plus 1 equals 4z plus 9. The diagonals bisect each other, which means they're congruent to each other. So you can solve both these pretty quickly. Subtract some y. Now we got y minus 5 is 7. Add some 5. So pretty quick here. Y is 12. The challenge shouldn't be in the solving the equation part, but instead just setting up the equation. So if we go to this purple one over here, let's subtract some 4z. Subtract some 4z. And while I'm at it, I can subtract 1, because I'm putting my variables on the left and numbers on the right. Now I got 2z equals 8. And you can divide by 2. And we got z is 4. Hooray! So you kind of see the different properties. Let us set up different equations, and then you solve the equation. I did want to point out a couple of other things that you need to be aware of. If you look at example D, it's got quite a few variables going on here, and you can actually set up a lot of different equations. Like you could set up that these add up to be 180, or these add up to 180, or these add up to 180, or these add up to 180. But if you were to set up any of those, you'd see that there's two variables but only one equation. And that gives you infinitely many answers. You would have to set up two different equations and solve that system, which is not fun. But if you kind of think ahead and plan ahead, you're like, okay, well, I don't want two different variables. I just want one kind of variable. Well, if you look at what have the same kind of variables and see how they're related, then you can set up an equation that just uses those. And one equation with one unknown variable has one solution. And so I would use that these opposite angles are congruent, set them equal to each other and solve. And then these guys are also congruent. So I'd set up the equation and solve that. But we're going to look at a few other things. I just want to mention on C. We haven't seen one like this before, but if it's a parallelogram, opposite sides are congruent. So you can just set this equal to this and solve it. These are pretty quick. So you can set those equal and solve them because they're opposite sides of a parallelogram. So is that, I do want to show a few notation things just so you can remember them in the practice section. We went over this earlier, but if you have DG with a line over it, that means side or segment DG. So look over here, DG. And then this next symbol isn't congruent. It's two vertical lines. That means parallel to. So you're looking for, whoa, what is parallel to side DG? You come over here. DG is parallel to the one across it, which is EF or FE. And so I'm going to complete the statement here. I put FE. You should put a line segment over it. And now we've completed. Those are parallel. We're going to skip 3 because we already talked about 3. This means congruent. This means side. So GH is congruent to what side? The other thing we haven't talked about is this one here. This little angle symbol in front means angle. And when you write out angles, we tend to put 3 letters just to draw out the angle. So the angle GDE draws the angle. So DGE goes like that. Okay. When you draw from letter to letter, it draws the angle. So yeah, that one can be a little tricky. This is congruent to something. Well, to get that something, you have to remember something about parallel lines and transversals. So we already know these two sides are parallel to each other. Add a little arrow there. And if two lines are parallel and you have a line that cuts across them, the alternate interior angles are congruent to each other. And what that means is this angle and this angle are congruent. So I'm going to put a little congruent mark there. And so now we need to name this angle. Well, the two sides that go off from it hit F and G. And so you can write the angles FEG, or you can do GEF. Both are fine. So I'm going to put that angle FEG is the other one there. So yeah, that one kind of remembers, you have to remember a few things about parallel lines and transversals. So, kind of drawing deep on your knowledge. But yeah, that's what's going on. A lot of parallel lines, a lot of parallelograms, and using the properties to solve for unknown things. So there you go. Use the properties. Good luck. And may the odds be ever in your favor.